So obviously, inorganic trace minerals are the most commonly supplemented sources of zinc, copper, and manganese to diets of cattle. So here are examples of inorganic sources: zinc sulfate, copper sulfate, manganese sulfate. There are other salts that can be used, but those tend to be the most commonly fed because they tend to be highly soluble within the sources of trace minerals, as opposed to, for example, oxide sources that are poorly soluble in aqueous solution. You can see that these trace minerals have some degree of hydration, but because of their solubility, they tend to be available in the rumen as well as in the small intestine. So when we have sources of trace minerals that are soluble in solution, obviously one of the expectations is that they will solubilize, and that soluble material will eventually ionize, as it's illustrated here in the case of copper sulfate that's pentahydrated. In solution, copper sulfate can solubilize and can dissociate it into ionized copper, divalent copper, and sulfate plus water. Okay, and this ionic copper can have antibacterial properties. This is why in dairy farming it's not uncommon to use copper as antibacterial, for example, in footbath solutions or during treatment of animals that have hairy heel warts or other problems. Okay, but this will also happen in other situations, such as when consumed by the animal and when present in the rumen. The same is true for zinc sulfate. Zinc sulfate in solution can solubilize, and once it's soluble, it can ionize, now forming the divalent zinc ion, which also has antibacterial properties. So you will see that in our discussion today, at least in the introduction, we're going to mention that these antibacterial properties, which are important in some aspects, may actually be detrimental when supplemented in the diet because of effects on microbial population in the rumen. So one of the concerns or issues with sulfate sources of trace minerals is that although they have the benefit of being soluble, which improves absorption in the small intestine, they can also have antibacterial effects in the rumen. And the ionic form of that metal can suppress microbial growth, which can affect digestibility. So it can influence digestibility of fiber, for example. In some particular cases, it can reduce consumption of trace minerals. This has been shown primarily in beef calves in range conditions, in which supplementation of sulfate source of trace minerals can reduce supplement ad libitum intake compared to other sources of trace minerals. And it can also degrade other compounds, such as the pro-oxidant properties, for example, of copper, that can have in fatty acids or lipid compounds. But we're going to focus on this aspect briefly, showing the effects of different sources of trace minerals on fiber digestion in the gastrointestinal tract. Well, sulfate sources are typically ionic bonds, yeah? So they have a weak bond, and this is what makes them soluble, which is beneficial for bioavailability. Organic trace minerals have covalent bonding, and here you have an example of copper being covalently bound to an organic compound, such as something that has carbon, oxygen, and nitrogen. And then we have hydroxychloride that have this stronger covalent bond that prevents them from being ionized in solutions with a pH close to the neutral pH or an alkaline pH. So when we have hydroxychloride compounds, they tend to be insoluble in the typical rumen pH, which is between 5.8 and 7.0. However, when they undergo the acidic environment of the abomasum and the early duodenum, they tend to ionize when the solution has a pH that is quite low because of the pK of that particular product. Okay, so sulfates are expected to be mostly soluble in aqueous solution at the typical pH of the rumen, whereas hydroxychloride and even organic compounds, they tend to be stable in that environment, and they only become ionized once they escape the rumen and they get to the small intestine or the abomasum with the low pH of that environment. So needless to say that both are inorganic source. Both sulfates and hydroxychloride are inorganic source. Okay, the difference is just the type of bond that they have with other elements in that particular salt or compound. So these are the hydroxychloride trace minerals that are typically used to be fed to ruminants. So when pH is high, still acidic, but close to the neutral pH, or typical of what the rumen has, this makes these products insoluble, making them not ionizable. So remember that for a chemical compound to release the free ion, it needs to first solubilize in solution. Okay, because they are insoluble, this makes them not reactive in the rumen. However, once they are exposed to the pH is close to 2 or 2.5 of the abomasum and early duodenum, and even at later portions of the duodenum that in the ruminant typically has an acidic environment because of the low secretion of, or the limited secretion of bicarbonate by the pancreas, this makes them to ionize and allow them now to become in the free ionic form that can be transported across the intestinal epithelium, as we will briefly see in a minute. So these are data from Colorado State University, in which they looked at solubilization of two different sources of trace minerals. So here we have the sulfate trace minerals, and here we have the hydrox trace minerals. So we can clearly see that in solution, the sulfate trace minerals solubilize more of the zinc source. Zinc sulfate is more soluble than the zinc hydroxychloride in solution. This is also true for copper and to a lesser extent for manganese. Okay. So there's a lot of data in literature indicating that sulfate sources are more soluble in solution than hydroxychloride, but hydroxychloride solubilized once the pH is very low, which typically happens in the abomasum and in the duodenum.